So the objectives are pretty much all about real numbers, the types of real numbers, the properties of real numbers, and we're going to order numbers and place value. I will tell you this is going to seem very easy at the level you guys are all at in your math careers. As you've noticed from math classes, they all build on each other, so we kind of have to reset the foundation and move from there. So if you think today is too easy, don't get too comfortable. It will get a lot harder. All right, so here's your first definition. It's a natural number. So natural numbers are also called the counting numbers. Numbers like 1, 2, 3, and 4. 0 is not a natural number. I like to think of natural numbers as numbers you would encounter in nature. So you wouldn't go walking and say, oh, look, there's 0 birds in the sky. You would probably only recognize something that started with a 1. 0 is not part of this set. Neither are fractions or decimals, just whole numbers, not including 0. Any questions on what it means to be a natural number? All right, the second type of number is a whole number. This is when it does include 0. The way I remember it is whole number has an O in it. O's look like zeros. That's the way I distinguish it from natural numbers. But it's all the natural numbers plus 0. All right, next we have integers. Once you look at integers, that's when the negative numbers start to come into play. So they're the negative and positive counting numbers, including 0. Again, we have not introduced any decimals or any fractions. Next, we'll look at rational numbers. Rational numbers are any number that can be expressed as a ratio. Ratio is another way to say fraction. When written as a decimal, they can be terminating or repeating. So any fraction, any number you can write as a fraction is considered a rational number. Something like 0.33333, where the 3's are repeating, that's actually 1/3. You can write it as a fraction. If the decimal terminates, of course, you could write it as a fraction. Just put it over a power of 10. So any repeating or terminating decimal or any fraction is also considered a rational number. Next, we'll talk about irrational numbers. So irrational numbers are numbers that cannot be expressed as a ratio or fraction, depending on how you want to think about it. When written as a decimal, these are decimals that go on forever without repeating. Now, some people get confused by that. For example, if you look at this one, there's a 1 here and there's a 1 back here. Unless this one was followed by a 4, 5, 2, 8, 7, it's not considered repeating. So, of course, the same digits will repeat, but as long as the same pattern isn't repeating over and over, that's what you need to check on, okay? So I like to think of irrational numbers as kind of big, ugly numbers. If you type pi in your calculator, it'll fill up the whole screen. It won't stop. It won't repeat. Same thing for the square root of 2. If you type that in your calculator, it'll fill up your whole calculator screen. It won't stop. It won't repeat. So those are the irrational numbers. Sometimes you can get tricked by an irrational number. I've seen ones where they don't start repeating until like 17 digits out. So it might look on your calculator like it's not repeating when it really is. In this class, I won't try to trick you with anything that doesn't start its repeating till the 17th digit or something. But just be aware of that. In some of your classes in college, they might try to trick you. So just be careful. But as far as this class goes, anytime it's kind of an ugly looking decimal, no pattern being established, it's going to be an irrational number. Any questions on that? Here's a nice little graphic, kind of helps you see how these all fit together. So your smallest set are the natural numbers. From there, when you add 0, that takes you to the whole numbers. From the whole numbers, when you add the negatives, you get the integers. All integers are rational numbers. Rational numbers just includes things that are decimals that repeat, terminate, or any fractions. And then over here you have your ugly numbers, the ones that repeat forever and ever. All right. I think this is a good visual. I'd put it in my notes if I was a student, just because it kind of shows how these sets build upon each other. You guys have any questions on this graphic? I'll give you a second to get it down in your notebooks. Here's just a little note. We kind of already hinted on this. The inner boxes belong to the sets outside of them. Here are some examples. So we're just going to list the types of numbers. I'm just going to use abbreviations. It just makes things a little simpler. So the number 17, anyone know? Yes?
It's a whole number.
Okay.
It's a rational number. And it's integer.
Integer, good. I'm going to go back and change that to integer. Rational.
There's one more. Oh,
It would be on the front.
irrational? No.
Natural. It's a natural number. Yep. Oh, I forgot this board kind of cuts off. Sorry. But yes, you should have N for natural, W for whole, I for integer, R for rational. Good. Questions on that one? How about 0? Yes, ma'am.
It's whole, integers, rational.
Very good. Basically the same as 17, but you got to knock off the natural. C, -4. Integer. All integers are?
Negative. No, positive.
Yeah. What else? What set? You had it. Yeah, they're also rational. Good. Just trying to trick you. All right, D, we have a fraction. What?
Rational.
Rational. Very good. All right, the square root of 17. Does anyone have a calculator handy? They can type that in for me real quick. What do you get? 4.123. 105. So basically a big mess, right? Good. Anytime it's a big old mess in your calculator, what would you put? Irrational. Good. You can't just put I because we're using I for integer, so irrational. That's negative, and then the square root of 144. What's the square root of 144? 12. So this is the same thing as a -12. What sets of -12 fall into? Integer and rational. Wonderful. G, we have another fraction, but anything special about this fraction?
4, so it's natural, whole, integer, and rational.
Good. It is a fraction, however, you can write it as 4, which falls into natural, whole, integer, rational. Good. The next one, 10.48, 48, 48, 48, and so on. Rational, good. Anytime it's a repeating decimal, it's a rational. However, down on I, the ... means it goes on forever with no sort of pattern associated with it. What would that be? Irrational, good. Next, we're going to talk about the properties. The first one is the commutative property. This property works for multiplication and addition. All it says is that you can add or multiply two things in any order. You will get the same answer. Here are some examples. 4 plus 5 is the same thing as 5 plus 4. 3 times 8 is the same thing as 8 times 3. You can also write it with variables. A plus B is the same thing as B plus A. Again, A times B is the same thing as B times A. So I'll give you a second to write those down. As you're writing, I will tell you how I remember this. In the word commutative is the word commute. So I live in Columbia. My commute is Columbia to Belleville. In the afternoon, it's Belleville to Columbia. So I drive in a different order, but it's still the same route. So commutative is just when the order flip-flops, but the answer does not change. All right, next we'll look at the associative property. This one also works for multiplication and addition. All this one means is that you can group parts of addition or parts of multiplication problems differently and still get the same answer. And there are a couple examples for you. So in the first one, this is an example using addition. The parentheses tell you what to do first, so you could add the 3 and the 7, then add the 4. You would get the exact same answer if you added the 4 and the 3, and then later added the 7. Same thing down here. A times B and then times the C would give you the same thing if you did B times C and then times the A. I'm recording. All right, distributive property. This involves multiplication with a set of parentheses. There are some examples for you. This is one that I'm sure you've seen over and over in your previous years. Basically, you're taking the 4 and you're multiplying it by each thing inside the parentheses. Down here, you're doing the same thing with the negative 7. So it works when you have parentheses next to something involving addition or subtraction. This is one of the properties you will use most often in any algebra class you take. Pretty straightforward. Any questions for me? All right, here's the identity property. There's an identity property for addition and multiplication. They're a little different. So for addition, adding a 0 to anything will not change it. It keeps its identity. So identity is who you are. If you took a number 5 and added 0 to it, it doesn't change who that 5 is. The identity stays the same. There's an example for you. For multiplication, it looks a little different. As you probably already know, to keep a number the same using multiplication, you would multiply it by 1. That would not change the number. Any questions on that? All right, the next property we're going to look at is the inverse property. For addition, this is just the opposite of the number. It's also called the additive inverse. For multiplication, this is just the reciprocal of the number. We call it the multiplicative inverse. Oops, sorry about that. Here you go. I'll write you some examples on here. So for addition, an inverse problem would look something like 5 plus a negative 5 gives you 0. So you're adding two inverses. It always gives you 0, so you could even change it to something like a plus a negative a would automatically give you a 0 no matter what a is. For multiplication, it looks a little different. If you had something like 5, you would multiply it by the reciprocal, which is 1 over 5. That would give you 5 over 5, which would give you a 1. Same thing with a variable. If we had a b and I multiplied it by a 1 over b, you'd end up with b over b, or 1. So those are some examples of the inverse property. The inverse property comes into play a lot when we're solving equations. I'm sure you guys know that from your previous years. If you can find the inverse, you can move something to the other side of the equation. It's very helpful. Any questions? So we are just stating the property. So name the property, and then you can just put a plus sign or a multiplication sign just to show me the operation that's going on. So number 1, the only thing I notice that's different is the parentheses are moving around. What property is that? Associative, good. You can abbreviate, but try to put a little more than 3 letters on that one. And are we adding or multiplying? Adding. So I'm just going to put a plus sign. So it's the associative property of addition. If you want to write that out in big long words, that is fine. I'm just going to abbreviate associative, and I'm going to put a plus sign for addition. What's going on in letter B? Distributive. Good. You don't have to say addition or multiplication here. It involves both. So distributive property is fine. You can see they're doing 4 times the 1, 4 times the 7. Oh, I see what happened. I was like, what is going on here? This, sorry, when I made my PowerPoint, should be up here. I was wondering what was going on there. I apologize. I must have changed the font and it just kicked it down a level. So for part C, just concentrate on this right here. And yes, what property is this? Commutative, good. It does involve parentheses, however, the parentheses aren't moving. They have the same exact thing in the parentheses on both sides. I guess the whole parentheses moved, but the placement of the parentheses, it doesn't change what's inside. So yes, this is commutative. And this is of multiplication, so you can put a dot or a parentheses or a times sign. It does involve subtraction in there inside the parentheses, but as far as what's going front and back, it's changing the multiplication order. So it is commutative and it's multiplication. D, the dangling problem. Basically, they're adding 0 to something. This set of parentheses takes you down to here. The parentheses did not change when I added the 0, so what property is that? Identity, good. I'm just going to put ID plus, since we added the 0. All right, on E, it looks like they added 8 and negative 8, and then when they rewrote it, they replaced it with a 0. It is the same thing.
Inverse.
But why is it the same thing? Good, it's the inverse property. And it's an addition. And then this last one. Anyone have any ideas?
Yeah, I do.
What's your idea? Associative. So what's in parentheses is different?
Yeah, it is.
Different order.
It's in a different order. What property is a different order? Commutative, good. Associative is when the grouping's changing. The grouping's not changing. The 8's with the A, the 8's with the A. The B's on the outside, the B's on the outside. So it kind of looks like associative, but gotcha, it's commutative. And it's multiplication. All right, here's our next set of examples. Basically, we are deciding which number is bigger, and then we're putting them on a number line. So the easiest way to do this, I think, is to change them all to decimals. Decimals are a lot easier to compare. They're also a lot easier to graph. So negative 4/3. Can anyone give me that as a decimal? Yeah, negative 1.3. Repeating, good. Can anyone give me the square root of 2 as a decimal?
1.41421356.
All right, good. All right, so the first thing I want to do is compare those two numbers. Which one is obviously bigger? Yeah, the positive one. So you would use this symbol. And then we're going to put them on the number line. The decimals will help us here. That first one is going to be past the -1, but not yet to the -2. So somewhere right around there. Whenever I'm graphing them, I usually go back to the problem because that's what they would be looking for. So instead of writing -1.3, I'd go back to the original -4/3. And then the square root of 2 is going to be almost right in the middle of the 1 and the 2. These don't need to be exact, but again, I'm going to write the square root of 2 instead of the decimal version. Any questions on that one? Pretty straightforward. Looking to problem B. The first one's already written as a decimal. That is great. Can anyone give me the decimal for negative square root of 3? Oh yeah, negative 7.3, and on and on and on. Good. Which one of those would be bigger if I was comparing them with the less than or greater than symbol? Very good. So the more in the negative you go, the smaller the value. I'm sure you guys remember that. Now I can go ahead and graph them. So this is going to be between the -4 and the -5. This other one's going to be between the -1 and the -2. Any questions on either of those? The decimals are really going to help us out in this next one. Can anyone give me 14/5 as a decimal? 2.8. Wonderful. Anyone have 7/4? Yes, ma'am? 1.75. Wonderful. When you go to compare those, it's super easy once they're in decimal form. Of course, the 2.8 is the greater value. And then we'll go ahead and graph these. So the first one's going to be almost to the 3, but not quite. And that's 14/5. The other one's going to be almost to the 2, but not quite. It's going to be 7/4. Any questions on these? But in case you don't have your homework sheet, this is the assignment for today. This will be due next time I see you. The answers for these are in the back of the book. If you have questions, we can go over them tomorrow. But by the time I see you, you should have all those problems done and all your answers checked. Come see me if you guys have questions on any of these.